Yo, what's up everyone? Welcome back, Patrick here. And in this video, what we got to do is find the domain of these three functions over here. So notice that all of these functions, they contain this expression, the square root of 16 minus 8 to the power of 3x, but they're very different here. It's just that expression, but here, that expression is in the denominator. It's going to be the reciprocal of that expression, and then here, it's in the denominator as well, but we have another expression in the numerator. So just wanted to show you, expose you to different cases where you can get an expression like this and they can be in different parts of a function. So let's go through these one by one. So we got f of x equals the square root of 16 minus 8 to the power of 3x. Now notice that we have a square root here. And whenever you have an even root, this could have been the 4th root, the 6th root, the 8th root, right? This is here the 2nd root, the square root. There's like an imaginary 2 here. Whenever you have an even root, whatever is under that root, that basically has to be greater than or equal to 0. Because you can't take an even root of a negative number. Right? You could take an even root of 0, square root of 0 is just 0, so that's why it's greater than or equal to 0, but it can't be negative. Now, if this was an odd root, like let's say there was a 3 there, then this could be negative, this could be 0, this could be positive, and then the domain of this would just be XER. X can be anything. But because it was an even root, there's this restriction that we have to work with. Okay, so just wanted to mention that to start. And so for here, what we got to do is just basically isolate for x in this inequality. So we can bring this negative 8 3x over, 8 to the power of 3x rather. Then here what we can do is get the same base. Like that. So we got 2 to the power of 4 greater than or equal to 2 to the power of 9x. And then that means 4 has to be greater than or equal to 9x. Divide both sides by 9 means x has to be less than or equal to 4 over 9, like that. Let me just make sure that everything is all good here. Yeah, looks all good to me, right? So that is the restriction on x. Notice that if we plug in any x value greater than 4 over 9, so let's say we plugged in 1. 1 is an x value greater than 4 over 9. If we plug in 1 here, notice we'd have 16 minus 8 to the power of 3, which is going to be a negative number. And we can't square root a negative number. So this is the restriction on x. And so different ways to write this domain. So we could say the domain is x is an element of real numbers, but x has to be less than or equal to 4 over 9. Another way to write it is we could say x is an element from negative infinity to 4 over 9. Because it's inclusive of that 4 over 9, we would put a square bracket right there. All right, so that ends up being the domain for this function. Now, what about if we take that expression and put it in the denominator, so the reciprocal of that? Well, it's actually going to be very similar to this. But because it's in the denominator now, it actually can't equal 0 anymore because you can't divide by 0. So before we had, when is 16 minus 8 to the power of 3x going to be greater than or equal to 0 up here? Well, in this case, notice we still can't square root a negative number. This is still going to have to be positive. But in this specific case, because this is in the denominator now, this can't be 0. So this would just be, we have to find when that expression is greater than 0, not greater than or equal to 0. And that's the only difference between this and that. And so it would be the exact same work, and we would just end up getting x has to be less than 4 over 9, not less than or equal to 4 over 9. Okay, so this ends up being the domain for this function. So we would have the domain XER x is less than 4 over 9. Or if we put in this format, x is an element from negative infinity to 4 over 9, and it's a circle bracket, not a square bracket. Right? Because it's not inclusive of that 4 over 9. Because 4 over 9, if we plug it in here, that's going to give us 0 in the denominator. All right, and then what about this third function? We got the square root of x plus 3 over the square root of 16 minus 8 to the power of 3x. So let's ignore this for now. We know this, because of this expression in the denominator, we know that x has to be less than 4 over 9. Like that for sure has to happen, right? No matter what is up here, it doesn't matter what is up there. We already know that for this expression, x has to be less than 4 over 9, because if it's going to be greater than 4 over 9 or equal to 4 over 9, then the function is going to be undefined because of that expression in the denominator, right? Or it's going to fail at that point, quote unquote. So we know this restriction on x for sure has to exist, but now we have another expression to deal with in the numerator. So we got to see, is there another restriction to deal with? And notice that there will be, because we have a square root of x plus 3. This is an even root of x plus 3. This could have been, again, the 4th root, 6th root, 22nd root. Any even root, we know that that expression has to be greater than or equal to 0. And it's greater than or equal to 0 because it's in the numerator. The numerator can be 0. The denominator can't, but the numerator can be. So that x plus 3 has to be greater than or equal to 0. If this root x plus 3 was in the denominator, then it would just be x plus 3 is greater than 0. So we know x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to -3. So notice x has to be greater than or equal to -3, but less than 4 over 9. And so if we combine those two restrictions, we can say x is an element of real numbers from -3, but x has to be greater than or equal to -3, but less than 4 over 9, like that. Or we can say x is an element from -3, inclusive of -3, so it's a square bracket there, to 4 over 9, not inclusive of that, so a circle bracket, right? So that ends up being the domain for that function.